Okay, section 3 on the cross product of two vectors. So the cross product is another type of multiplication when dealing with vectors, this time dealing with vectors in 3D. So we're going to say u crossed with v, and it's another type of multiplication. The formula is typed out here, but we're not going to use the formula when we solve these problems. I'm going to show you a shortcut that I use to solve the cross product, but you're more than welcome to use the formula. Here are some properties of the cross product. Normally when multiplying, it doesn't matter the order that you multiply, but with the cross product, order does matter. So if you do u crossed with v, that is not equal to v crossed with u. It's actually the opposite. Okay. The second property, u crossed with v plus w, you can think of using the distributive property here and do the cross product between u and the two different vectors and then add them together. Third property is multiplying by a scalar. When multiplying a scalar times the cross product, you would just multiply that number times one of those vectors and then do the cross product. Then we know that anything times 0 is 0, so those next two properties make sense. When you actually do the cross product between a vector and itself, it equals 0. And then the last property is called the triple scalar product, and we'll be using our calculator when we get to the triple scalar product. Here are some geometric properties of the cross product. Some of them we'll be using in this lesson. So when you do the cross product between two vectors, the new vector is orthogonal to the original two. So that means it's perpendicular to the original two vectors. If the cross product is equal to 0, then they are, if u and v are scalar multiples of each other. So that means they're parallel. The magnitude of u crossed with v is the area of a parallelogram having u and v as adjacent sides of the parallelogram. Okay, the triple scalar product, like I said earlier, we're going to put three different vectors in a matrix in our calculator, and then we will find the determinant of the matrix. And then the last thing, volume of a parallelepiped. A parallelepiped is a three-dimensional parallelogram. So if I wanted to find the volume of that, I'll actually find the triple scalar product using my calculator as well. Okay, so example 1, we're going to find the cross product of I and k. Like I said, you can use this formula if you want to. It's hard for me to remember what's what and what to multiply, so I'm going to use this process that I show you. So I'm going to write our two vectors in a matrix with the vector ijk in the very first row. Now I'm going to be crossing some things out as we're working through this. You don't want to cross it out on your paper because eventually you'll have marked everything out in the matrix. So you can just kind of cover it up if you want to, or if you wanted to use a highlighter, that would be fine. So first I'm going to cross out the first row and the first column. I'm going to ignore those, and I'm looking at this 2 by 2 matrix. And I'm going to find the determinant of this 2 by 2 matrix, and that's where you multiply across and subtract the answers. So if I do 0 times 1 minus 0 times 0, I'm going to write that out to the side, 0 times 1 minus 0 times 0, and then an I afterwards. Okay, next we're going to go to the next column and mark it out. Then we're going to multiply across again. So 1 times 1 minus 0 times 0 this time. Now after the I will always be a minus in the formula, and then the numbers that we just multiplied out followed by j. So minus 1 times 1 minus 0 times 0, j. Last column, we're going to do 1 times 0 minus 0 times 0. And that will have a k. Then we're going to simplify in each parenthesis and reduce those parentheses and write them as one term. So 0 times 1 minus 0 times 0 is 0i. 1 times 1 minus 0 times 0 is a 1j, but there's a negative in front, so that'll be negative 1j. And then 1 times 0 minus 0 times 0 will be 0k. So this is written as a linear combination. I could simplify this further and just write it as negative 1j or negative j, or I can write it back as a vector, which would be 0, negative 1, 0. So this vector is the cross product of the original two vectors, and it would be perpendicular to the original two as well. Okay, same thing on number 2. We've got two different vectors, u and v. We're going to write them in a matrix again and follow the same procedure. So I'm going to ignore the first row, and I'm going to cross out the first column. We're going to multiply 0 times 0 minus 0 times 6. And I'm going to put an I afterwards. And we're going to cross out the middle column and multiply negative 10 times 0 minus 7 times 6. And remember, right after the I, always put a minus, then your terms, and a j. Last column, we're going to do negative 10 times 0 minus 7 times 0. And then a k. So when I simplify each of these, we're going to get 0i plus 42j plus 0k, which you could write as 42j, or in component form, 0, 42, 0. Okay, number 3, we are going to do the cross product of u and v, but we were supposed to find a unit vector that is orthogonal to u and v. So after we've done the cross product, we're going to plug them into this formula for a unit vector. So remember, these are written as a linear combination, so vector u is actually 3, 1, 0, and vector v is 0, 1, 1. So same procedure, we're going to cover out the first row and the first column, and we're going to multiply 1 times 1 minus 1 times 0, I. And then remember, after the I, always put a minus. We're going to do 3 times 1 minus 0 times 0, j. 3 times 1 minus 0 times 1, k. When I simplify each set of parentheses, this is going to simplify to 1i minus 3j plus 3k, which is the vector 1, negative 3, 3. Now, this is an orthogonal vector to the original, but we want to find a unit vector. So in order to find a unit vector, we're going to divide this vector by its magnitude. Okay, so we're going to take the vector that we already have and divide by its magnitude. So remember, the magnitude is just like the distance formula. So we're going to do the square root of 1 squared plus negative 3 squared plus 3 squared. So this is going to be the square root of 1 plus 9 plus 9, which is the square root of 19. We want to leave it as the square root of 19, so that when I plug it into the formula for a unit vector, we have the vector 1, negative 3, 3, divided by the square root of 19. We can't leave the square root on the bottom, so we'd multiply times the square root of 19 on the top and bottom, and it would give us the square root of 19 over 19 times 1, negative 3, 3. You could distribute the square root of 19 over 19 into the vector, or you can leave it out front. Okay, number 4, we're going to find the area of a parallelogram that is made up with these two vectors. So we're going to find the cross product and then the magnitude of that vector, and that will give us the area. So same as before, we're going to put these two vectors in a matrix with ij and k, and we're going to go through and find the cross product. So cross out the first row and first column. We're going to do 2 times 3 minus 2 times negative 3i. And then minus 2 times 3 minus 0 times negative 3j. And then plus 2 times 2 minus 0 times 2k. So when I simplify each parenthesis, I'm going to get 12i minus 6j plus 4k, and that's the vector 12, negative 6, 4. Then I just need to find the magnitude of this vector to find the area of the parallelogram. So this is going to be the square root of 12 squared plus negative 6 squared plus 4 squared. So that's the square root of 144 plus 36 plus 16, which adds to the square root of 196. Then when I take the square root of 196, that equals 14. So the area of our parallelogram is 14 units squared. Okay, on example 5, we're going to find the area of the triangle. So this is the same process as before, since a triangle is just half of a parallelogram. So we're going to find the cross product and the magnitude and then just divide by 2. Now for this triangle, we've been given 3 points instead of vectors. So I need 2 vectors that make up the triangle. So if I find the vector AB, it is negative 4, negative 5, 5. And the vector AC is 1, negative 3, 11. So then I'm going to find the cross product of these 2 vectors. So IJK, negative 4, negative 5, 5, 1, negative 3, 11. Okay, so we're going to do negative 5 times 11 minus negative 3 times 5, I, minus negative 4 times 11 minus 1 times 5J, plus negative 4 times negative 3 minus 1 times negative 5k. So this simplifies to negative 40i plus 49j plus 17k, which is the vector negative 40, 49, 17. So now we need to find the magnitude of this vector and then divide by 2. So this is the same as 1/2 of the square root of negative 40 squared plus 49 squared plus 17 squared. So this is 1/2 of the square root of 1600 plus 2401 plus 289. So that's 1/2 the square root of 4290, which is approximately 32.75 units squared. Okay, so on number 6, we're going to find the triple scalar product, which is technically the same process that we've been using to find the cross product between 2 vectors, but this time we're going to put 3 vectors in a matrix, and we're going to let the matrix do the work. Our calculator won't do it with i's, j's, and k's. That's why we have to do the cross product by hand. But for the triple scalar product, we can set this up as a matrix in the calculator. So you're going to go second x to the negative 1 and go over to edit A, and you're going to enter this as a 3 by 3 matrix. Make sure you put them in the correct order, U, V, and then W. After you've typed your matrix in, then you need to go back to the home screen by hitting second mode. Then you're going to type second x to the negative 1 and go to math and look for the determinant and hit enter. Then do second x to the negative 1 matrix A. So your calculator is going to say determinant of matrix A, and then you're going to hit enter, and you should get negative 16. So that means that the triple scalar product for this is negative 16. Okay, last example, same process. We're going to find the volume of the parallelepiped. So remember, a parallelepiped is just a 3D parallelogram. So we're given the 3 vectors that make up this parallelepiped, and we're going to plug them in a matrix, same as last problem. So we input our 3 vectors as a matrix, and then we're going to do the determinant of this matrix also. So the determinant of matrix A, and this one you get negative 12. Now for volume, it should be a positive answer, so you just take the absolute value of whatever you get. So the volume of this parallelepiped is 12 units cubed.